Well, good afternoon. My name's Larry Gastiger. I'm the Executive Director of Wires, and I want to welcome everyone to today's session on advanced technologies, which is the latest in an ongoing webinar series that Wires offers that focuses on various advanced and innovative technologies and how they help us with expanding the grid and getting more out of our usage of the grid. And today I'm very pleased to have with us Ampjack, who's going to talk, and they're going to talk to us a little bit about how they use technology to raise up transmission towers and get more clearance underneath the transmission that we have in place today. And with us, we've got three folks from Ampjack. We have Luke Chaput, who's president of Ampjack. We have Nathan Stahl, who's the vice president of engineering for Ampjack, and then we also have Mike Haight, who is the director of business development for Ampjack. So we've got three of Ampjack's top folks here to talk to us a little bit about how their process works. And actually, they've got a video that they're going to use, and so something new for us on these series that I'm looking forward to as well. So with that brief introduction, oh, actually, before I get into that too, I want to mention to the people who are viewing, we are going to have the ability for folks to submit questions for Ampjack to talk about their technology. And I would encourage folks to provide questions for them. They're happy to talk about the technology that they use. So in order to do that, all you have to do is on the right-hand side of your screen, there's a question function. If you click on that, you can type in a question, and we'll work that in once we get towards the end of their presentation. So please think about some good questions for us to raise with them. And now without that, I'd like to move over and let the folks from Ampjack go ahead and introduce their video, and then we can get into a discussion about how things work with theirs. So I'll turn it over to you guys.
Great, thank you, Larry. As you mentioned, we're going to be talking about energized tower raising, utilizing your Ampjack method today. So Drew, if you want to go ahead, we have a brief 4-minute video just to kind of introduce what the technology is, and then we'll get into a little bit more of the question and answer portion that kind of goes through what we do in a little more detail.
The power grid, majestically installed all over the world, has been doing its best to keep up with the changes that are being asked of it. As the industry is constantly thinking of ways to generate new energy sources and their associated demand on the grid, we also need to think of new ways to improve how we maximize what we already have. Although utilities are constantly planning new transmission line projects, the grid continues to be stretched to its limits every day. Innovative, efficient, and sustainable solutions are critical to the advancement of power flow through existing transmission line assets. Now more than ever, we need to take bold steps to increase power reliability and significantly improve the grid that has served us all for so long. The Ampjack tower raising system is the tool and the approach to quickly lift the grid to where it needs to be today. Eliminating costly environmental processes and lengthy permitting cycles, the Ampjack team uses existing structure access and established tower footprints to perform our work while the line remains energized. Whether it be on a steep cliffside or on a faraway hilltop, our patented system is designed to be used in the most challenging and remote locations. With over 1,000 tower raises to date across all voltages, there isn't a tower that we can't improve. As a fully engineered solution, all our processes, methods, and procedures are meticulously developed to ensure seamless execution in the field. From isolated clearance mitigation issues to complete line re-rating projects, our team has the experience and the knowledge to get the job done. Our power grid desperately needs our help, and a new holistic approach as an industry will get us there. Environmentally sustainable solutions are essential in providing clean, reliable, and affordable electricity moving forward. Helping energy providers around the world get the most out of their existing transmission line assets is what we do. Making a difference today for future generations is what we're all about.
All right, great. Well, thank you guys for that. There were some really great visual images associated with the work that you wind up doing, and have some questions that I thought I'd start with, kind of get us into a little bit of a better understanding about how this all works, and give people the chance to think a little bit about what questions they may have to ask you guys later on in the presentation. But Luke, let me start with you, since you're the founder and you're the inventor of this process. And I'll just start off with a pretty high level question, but where did this idea come from to try and use engineering to raise the transmission towers?
Thanks, Larry, and thank you for the opportunity. It's a great question, and it's a bit of a fun one. So, the short answer would be, well, every need like this is born out of a need for the industry, right? Something we're looking to do. But this one was a bit more interesting. We had processes that were allowing us to do work like this. We've been using those processes, for 30, 40 years, using cranes and large equipment and such. And we got involved. So back when I was a little bit younger, got involved in doing some engineering analysis and upgrade solutions for utilities all across North America. And we were providing solutions, construction style solutions that were using old practices. So what the challenge came up was, can you be more economical? Can you be safer? Can you be more environmentally friendly? And can you do all that without impacting, schedules and environments and all of those things? So ultimately, it came down to, sort of taking a step back and setting a set of goals, trying to, develop something that was going to achieve something we had never done before, and was going to allow our clients the opportunity to do something they couldn't do, which was energized tower raising. And we can get into more why we do tower raising in general, but ultimately we weren't back then doing energized tower raising. We were doing it with cranes and taking outages, and there was a large impact on the environment. And we really needed to come up with a better solution. And that was where the whole idea came from.
Thanks. Got to get off mute there for a second. Let me turn over to Nathan. I'm curious because I know you are one of the lead engineers for Ampjack, and video indicates that the company's been doing this for over 1,000 tower raises. Curious, what have you seen in terms of any type of a shift in utility needs over the past 10 years in conjunction with this type of a work project?
Yeah, no, that's a good question. So, as Luke had mentioned, the industry has been, lifting towers, doing tower raising for quite a number of years, using conventional methods, cranes, aerial devices, de-energizing circuits to complete the work. And when we started Ampjack and started lifting towers using the Ampjack system, a lot of the requirement to lift towers was associated with spot clearance mitigation, targeted towards things like NERC alerts or point of interests on a right of way. From original construction, it could have been tied to changes in the right of way itself, developments, crossings, whether that be railroads, pipelines, underbuilt. So more of a targeted clearance mitigation approach, high wide corridors, with changes in transport vehicles and agricultural equipment, more of a targeted approach to clearance mitigation. In the last number of years, 5 or 6 years, I'd say we've seen a shift to more of a larger scale transmission capacity increase approach, right? Tapping into residual capacity that utilities may have in their transmission system, in their specific transmission lines, right? Tapping into trapped capacity. So, when lines were originally built and developed, there may have been, select spans that curtailed the capacity of that line, and now we can you know, with larger scale lifting of the broader transmission line, we can increase capacity of a transmission line and the system. We've seen a significant increase in integrating reconductoring and tower raising, right, for very large capacity increases. So those have been kind of the biggest shifts over the last 5-6 years. Really just larger scale in terms of you know, the quantity of towers on a given transmission line and why we're lifting those towers. But we've also pivoted into working with system planning, the system planners, for overall, you know, system upgrades, right, to the capacity needs and the goals of the utility operators.
So Nathan, let me follow up with one question related to what you just said, because I'm not an engineer, so I don't understand all this stuff. But can you just explain or elaborate a little bit more for me? How does raising the tower help you expand the capacity? Is it just simply through reconductoring, or is there some other aspect of it?
Yeah, so ultimately the capacity of a transmission line, the ampacity is the ampacity that we can transmit within a line, within a wire system, is related to the thermal properties of that line. You pump more ampacity, your wire system heats up. As your wire system heats up, it sags closer to the ground, right? And that's where ultimately tower raising comes into play. If you had a transmission line that was originally designed to operate at 60 degrees Celsius, as an example, you know, that has an associated ampacity rating for that transmission line. But if you were able to operate that same conductor to 90 degrees Celsius, there's going to be greater sag in the wire system. And so by lifting structures, we're able to tap into that reserve capacity in that wire system.
Okay, even as a non-engineer, I could actually understand that. So thanks, Nathan. Appreciate that. Luke, let me turn back to you again, because you know, Nathan was talking about how the situation has changed or transformed a little bit over the last 10 years to now, you know, it being part of the system planning. Can you talk a little bit about how Ampjack relates to overall system planning benefits?
Sure, absolutely. Thank you. So touching a little bit back on what Nathan was talking about, and then going into a bit more depth here. So every utility pretty much in the world right now is all struggling to figure out how to get more generation, more economical, more environmentally friendly generation connected to the grids. Unfortunately, or the challenge with that is that a lot of the renewable energy that we're generating is often a long way away from our load centers, which would, you know, typically be our cities, right? So the big challenge is, how do we get the new generation from point A over to the load center point B? And that involves often building new transmission line. We all also know how, you know, the utilities worldwide are all struggling to figure out how to build new transmission line quick enough to resolve some of these issues. There's all kinds of funding available, and the news in our industry, that's all that's talked about every day. You know, there's an announcement every day on funding and money available and changing potential legislation and policies to allow it to happen, but it takes time, right? So what the Ampjack system allows a lot of system planning groups to do is sort of look at their existing system. Now you got to remember, if you don't have a solution to something, and backtrack a little bit, if you don't have a solution to something, or a tool or a method to do something, then you can't think forward and plan to use it, right? So once you understand that, oh, there is something I can do with this new tool, then you can start to plan and generate new ideas and plan to use it. So what this is allowing our system planners to do is say, okay, I now have the ability to economically, environmentally friendly, and sustainably increase the capacity of certain lines. You know, and there's caveats to all of those. It needs to go through, you know, studies and such. But lot of our existing infrastructure out there has what we call residual capacity. What this is doing is letting them look at those existing lines, make assessments, and then say, all right, let's plan to do an increase based on some of our limits. And knowing we can run our wire hotter or temperatures hotter with more ampacity, those types of things, and see what we can get additionally out of our capacity. And often we're getting 10, 20, 30, even up to 40% capacity increases, just by increasing the operating temperature of that line, which means we're increasing the sag of that line, where Ampjack falls into place, right? By helping increase the tower heights to allow them to operate at those times. So sort of trying to round all of that back up to why it's important is if we can get 10, 20, 30% more capacity out of our existing infrastructure right now, that may solve the issue in certain areas completely, but it may, and it may not, and you may need more capacity than that, but it helps bridge that gap until we can get our permits in place, get our new construction, notices of proceeds from whichever regulatory body you're challenged with, and trying to get those developments underway. None of that goes quickly, and we have the opportunity, and we're hoping to share the opportunity with a lot of our clients that they are able to bridge some of those gaps with immediate or very quick economical, environmentally friendly solutions to getting more capacity. Does that sort of answer the question there for you, Larry?
I think it did. Mike, let me turn to you because I wanted to ask a little bit about the video highlights some of the operational benefits associated with using Ampjack process. Can you circle back and highlight some of those or elaborate on what some of those operational benefits might be?
Sure, thanks, Larry. Obviously, you saw in the video, there's a big shift in terms of what we need to utilize for our Ampjack system versus traditional tower raising or tower erecting methods, or as Nathan mentioned, there's other ways to gain more capacity in the existing transmission system. Tower raising is just one of those tools in that toolbox. But what makes it very unique and different from even a lot of the other technologies that have been presented here on Wires and other associate members that have great, products and services as well. As far as I know, most of or all of the other technologies require outages to do the work in order to gain that additional capacity. What really sets Ampjack apart, from an operational standpoint, first and foremost, is the non-outage requirements quite often to do the work. About 95% of what we do is on energized circuits. So we're actually raising the tower without taking outages and, not having to be faced with the outage challenges. One, can you get them? A lot of times in certain areas, we're all, utility folks, we understand outages are harder and harder to come by. You get a shorter window. Can you complete the construction in that time? Weather rolls in, I'm up in the Northeast myself. We've had some rough rain and cold weather coming in here. Crews are standing down and it's tough to get the work done. If you're faced with a certain time frame in order to complete construction and you can't do it in that time frame, when is the next outage coming? So there's a lot of challenges with doing outage work, aside from the cost and the, reliability of the system. It just allows us to do our work a little bit easier without being in a window outage, or an outage window, excuse me. And then if you saw in the video as well, obviously we're not using any cranes, bucket trucks, no heavy aerial equipment to actually perform the work of doing the tower raise. So it allows us to work within a very small footprint around the base of the structure itself, what could be considered that already disturbed or maintenance area around the tower. Allows us to get into very small areas, remote access. We don't have to build a lot of matting or excessive roadways to get our equipment in. So it is much more environmentally friendly. It's a much safer work practice when we don't have that much equipment on site. Allows us to work in very congested corridors where you've got other transmission, railways, pipelines, shared right-of-ways that we can get in and get out a lot easier with a couple pickup trucks, a flatbed, a little skid steer, rather than having to build excessive access roads to bring in heavy equipment. It also allows us to airlift all of our equipment into sites. We work in certain areas where there are little or no road access, not easily at least, and it would be very costly to rebuild, the roads back into these places where some of these remote mountainous or river wetland areas are. We can actually fly everything in with a helicopter, including our personnel, and never actually put a piece of wheeled equipment on site. So it allows us to get to places that just simply are not as easily accessible to other technologies and other solutions. And like Luke mentioned, last thing, the permitting that's required on a lot of these projects, because we're not building excessive roads, we're not bringing in heavy equipment, sometimes can be reduced or completely eliminated in certain cases. That allows us to do work that, simply just takes years or may not ever be able to get a permit from a borough land management or a certain, environmental agency that just says, no, you can't drive through a certain area. Well, we have ways of getting around that because our equipment is small and able to be brought into some of these tricky areas.
So Nathan, I'm going to turn to you because I think I've heard all three of you talk about environmental benefits or advantages around environmentally sensitive areas. Can you elaborate a little bit more on what those really are and how does the system actually benefit the environment or provide environmental benefits through its use?
Yeah. So Mike had a lot of good points on the benefits and kind of the resulting environmental impact or reduced environmental impact of the construction method. But when you compare, or when you look at an Ampjack system, an Ampjack lift, really our goal is to use existing infrastructure, pivoting away from, the tear down and replacement of, serviceable infrastructure that is already in place, serviceable transmission lines. And that results in a much more sustainable, environmentally sustainable construction method, right? When we're able to use existing structures, upgrade them, for required capacity, current codes, current standards. As part of the engineering approach, that we go through, the detailed engineering, we're looking at the wire system, the structure, the foundations. We're bringing it up to current codes and standards, all through these construction methods that do have less impact, lighter equipment, smaller footprint compared to the traditional methods or the alternative of tearing down and replacing existing transmission systems, right? So a lot of those items that Mike talked about really tie in very closely to the more sustainable approach, the less environmental impact. The Ampjack system it's a modular lift system, right? So the individual components are built and then assembled into the tower to complete the upgrade. And whether we're doing tower lifting, tower repair, retrofit, any of the upgrade packages that we develop, associated with a raise and upgrade project, it's modular equipment. It's sized so that we can heli transport it to an inaccessible site. And so when we are accessing, the site location compared to, traditional construction equipment, we've got crew trucks, we've got light trailers, eliminating, the large, heavy impacts on the right of way. That does cause a significant impact on the right of way, on the environment. By saving the existing structure, we're making considerable reductions in the amount of construction material, right? Yes, towers need to be upgraded and brought up to current standards, but we're able to do that in a sustainable way by leveraging those existing structures. Foundations, same thing. By looking at the foundations, upgrading foundations when needed. An upgrade compared to a new foundation is really quite, environmentally quite a bit more sustainable in terms of the environmental impact. And at the end of the day, that's a reduced emissions associated with this construction method. And so, kind of all of those things that Mike, mentioned in terms of the operational benefits tie to a really a very sustainable and an environmentally friendly construction approach.
Well, Luke, I want to turn back to you because, safety is such a big issue in this industry. And I think I heard you mention that there are safety benefits associated with, the Ampjack process. I heard it in the video where I'm watching like a dozen guys crawling all over this infrastructure. And I want to come back to just loop back to you on this safety issue. Can you elaborate on why there are noteworthy or notable safety benefits with this process versus some other type of a process?
Absolutely, and you hit the nail on the head, Larry, when you said the industry is focused on safety as well, right? So ultimately, when you sit down and to develop a new method, new process, new tool, right, for to solve a problem or to make things better, one of the first things, the key focus is on safety, right? How do I improve that safety? There's often very great other benefits that come along with it, but you might be more economical, or maybe it's not. It might be more environmentally friendly. In this case, it is, and sometimes it's not. But when you focus on, for our industry and trying to introduce a new technology, it really comes down to, for acceptance, it comes down to being safer, right? So that's what we start focusing on, is how do I improve safety? Now, we've got a slide deck that you and the audience haven't been able to see, but we can certainly provide later, where we show examples of how we used to do tower raising using cranes. So we call it, we'll get right to the point, is ultimately we end up, if we're using aerial devices to lift the top section of a tower or even the entire tower, we are doing so, we have what's called a suspended load. We have a load hanging from a crane above personnel working either on the tower or on the ground. So that comes with risks. I'm not going to say that it is unsafe, because we've done it for years and years, but there is safer ways to do things. You can always improve on safety. So what Ampjack does is really, it's a different process. It's a fully engineered process that starts with understanding all of the constraints, all of the loading on the line, the characteristics of that line, that structure, that foundation, and the wire system. It's fully analyzed and vetted out so that the actual lifting procedures and tool are an engineered process for that specific job. Now, there might be one tower in a line, or there might be 50 towers in a line that we're raising, but all of them are looked at. It's a fully engineered system. Nathan mentioned it. We look at the wire system, we look at the structure, and we also look at the foundation. So we have a very different understanding of, and a broader understanding of the risks that go into manipulating a structure while it may have the wire on it, while it may be energized, right? So and I talked about earlier where we didn't do this type of work typically in the past with the line energized. From our perspective at Ampjack, whether the line's energized or not is almost irrelevant, in the sense that it comes into play when there's imbalances on the line, whether or not the power is flowing or not. We developed the system so that we're so far away from the conductor that we're well outside, or we're a long way away from any of the danger zones, and it's ultimately almost irrelevant if the line stays energized for us. So we treat all lines as they are energized, regardless of if not. So there's, again, the benefit to the utility that we're doing it energized, but the bigger benefit to our crews is that they're staying well outside of any energized zone, and the tower is not suspended by a crane. It is what we call it having positive control. The Ampjack system has basically gripped the tower, and it has got control of it, and the tower does nothing until we decide to manipulate it. So what I mean by that is, once Ampjack is installed in the tower, and it basically is getting ready to take the load from the top of the tower down through the Ampjack system, and then relocate it to the bottom below our split location, right? So if you follow that load path, the load comes down the tower, goes into Ampjack, and then goes back to the tower, right? And in the middle there is our split location where we're going to install a new section of tower to make the tower taller. What the Ampjack does is has what we call positive control, like I mentioned, and it does nothing until we decide to go up or go down, right? The Ampjack is controlling the tower at all times. So it's a much safer process because we're not depending on, did we get the size of the crane correct? Is our crane pads stable? Is the weather going to cooperate? Because we've engineered the weather criteria into the system. There's all of these, factors that play into construction on an everyday basis that we consider during the engineering process and do everything we can to reduce or mitigate any of those challenges. We've got operating criteria that says we will not do something at a given wind or at a given temperature. It's a very broad range, but we still have operating criteria that all of our crews adhere to. Again, very, very engineered, very sophisticated method of doing something with a great result. And that's the key, of course, is again, when it comes down to our industry, there's the last thing I ever want to hear is somebody comes off the tower and says, I never want to do that again. That was terrible or horrifying or whatever it was. I want people to come off the tower and say, well, that was no big deal. I'll do that every day. It was so controlled and so, so smooth. And we get that from our clients when they come out and watch a tower raise demonstration. They're often saying, well, when is it going up? And we'll say, well, it's actually in the middle of going up right now. It moves so slowly. It's a 1/4 inch per second that most people can't even see it going up. But in 2 to 3 minutes, all of a sudden it's up 5 feet and we're installing new steel. That's how smooth and precise it is. And that's really what it comes down to is that increase in precision to reduce risk and increase safety.
Well, Luke, I want to stick with you for a second because we talked about some of the, various things like planning benefits, the environmental aspects around the process and how it works. Talked about safety, but always the big one is the bottom line, right? Let's talk a little bit about some of the economic benefits associated with using this type of a process where you can raise the towers without any outages. And actually, it was kind of interesting to me when you were saying it doesn't really matter to you whether it's energized or not when you're doing it. That also seems kind of remarkable in a way too. But I want to hear more a little bit about what some of the economic benefits are, so people get a better understanding of what those might be with this process.
Absolutely. So, and you've heard us all say a number of times, right? Outages. Well, when a utility takes a line out of service, right? We don't have transmission lines because they look great. We have transmission lines because they serve a purpose. They transmit power from A to B. And we have a system that counts on them from a reliability perspective from the reliability perspective. So like by two things economically come into play right away. If we don't have to take the line out of service, there's a continuous flow of power for the utility, which is generating revenue. Okay, so that's easy to understand. We're generating revenue by selling power. We keep the power on. Utilities make more revenue, right? From a reliability perspective, if you take one line out of service, what you've done is reduce the reliability of your network, right? So, because one line may be of the backup for a different line in that same network. So when you take a line out of service, there's reduced reliability. That comes with a cost often. So there's sometimes where, especially down, some of our very congested states where, I don't want to say down, I mean, are very congested states, some in the Northeast, some in the Southwest, where power is at a premium. When they take a line out of service, they're actually buying power from a neighboring utility to ensure they maintain reliability or just service in general. That comes at a significant cost because they're not producing their power at a fixed rate anymore. They're buying it for somebody on the open market, which can be expensive, right? The other sort of ancillary, economical benefits that come along with keeping the line, reducing outages and keeping the line in service. With Ampjack, you're reducing risk. We talked about that, and Mike talked about project management and planning and such. When you spend months and months and months of time planning your project, and all of a sudden right before you go or in the middle of completing your project, you have bad weather, or the utility says, hey, we need the line back in service because our neighboring utility lost a line and we need to increase reliability, or we lost a line and we need this one back in service, right? And you get shut down. Now you've lost all of that effort into planning and permitting and project management, so you're having to redo it. So by having the ability to do work energized, or even on short duration outages, which are a lot easier to get than long duration outages, you've reduced that risk and you've reduced the cost associated with that risk. The return on investment is another big one, right? If you can take the capacity of a line and increase it by 10 or 20%, when you run the numbers on the value of power, the value of electricity, it adds up so quickly to the point where we actually developed a calculator to get our clients' attention, where we show them, it can be over a 10 or 15 year period, it can be in the billions of dollars just with a small capacity increase, just based on what the value of energy is these days. Then from the perspective of reducing permitting and again, project management time, we've had clients tell us that, over the years, we've saved them dozens of millions of dollars in permitting costs alone, environmental permitting costs. So there's an opportunity, sort of, as to use Nathan's words, holistically look at this whole idea and pull together the benefits, the operational benefits, and sort of capitalize on that entirely, right? Whether it's from the safety perspective or from the economical or environmental or sustainable or reduced carbon, offset. We have clients who are trading carbon credits. When we've done studies where raising a tower using our method versus changing a tower out completely, so new foundations, new tower, cranes, all that equipment, we're about 10% of the carbon footprint of changing a tower out. It's 90% savings on the carbon emissions. That's significant. That gets people's attention, right? So those are the sort of the cost benefits, associated with the technology and equipment and the methods.
And I'll just add to that too, Larry. It's not necessarily in the financial benefits or costing of it, but we do get a lot of questions from utilities or some of the smaller municipals and RECs we work with. Is there's a lot of the federal money, DOE, USDA, that are available for funding some of these projects through grants, through partnerships, or however they allocate it. We have talked with the DOE, and we do meet the criteria to be considered part of the grid, enhancing technologies group. Although it's a physical upgrade to the system rather than some of the digital stuff that a lot of folks are working with right now. We do qualify and are able to be used for DOE grants and funding. And we've also talked with the USDA earlier, I guess it was later last year in Q4, that we meet their criteria as well. So if there's municipals, co-ops, RECs that are looking at transmission upgrade projects to either gain more capacity or to even just harden their system, that there is funding available for that too. And Ampjack, again, qualifies for that with the, you put a business plan together, submit it, and they can help fund some of those projects as well.
Good answer. Thanks, Mike.
I was going to say, thanks, Mike. You hit on the next question I was going to ask, which was, given that there are these new programs out there that provide different funding sources, whether there might be some ability to tap into those, and it sounds like there is. So I think that's really helpful to know. I'm just going to pause for a second and tell folks again that if they have any questions that they want to submit, to please put them in the question function. I'm happy to pass those along. I've got a couple more myself yet that I want to run through, and then we can hit anything that the people have submitted that they'd like to find out more about. And one of the questions I wanted to follow up on was, I'm just curious whether, does it make any difference what the voltage is or the voltage levels of the various transmission lines in terms of how this system works or not? And part of it is I just don't know enough about the system to know whether it does or doesn't make a difference. And I'll leave that over. I don't know whether that goes to you, Nathan, or Luke or Mike, or if none of you really want to touch it, but let me know.
No, I guess I can start with that, and Luke and Mike can fill in after. You know, what we often say is you don't start when you're developing a new method. You don't start with the biggest and the highest voltage, transmission lines out there. When we started developing the Ampjack system, we were lifting towers, 110, 115 kV circuits, and our lift loads were 15 to 20,000 pounds. Our system was, small, compact, in terms of the size of the system. And you complete that work, you develop lessons learned, you put that back into the mix, and you go for your next 230 kV, 345, 500 kV. And that's ultimately how we've developed our system, is learning and building capacity into the technology, the tools, the methods. Every project we complete, we go back into the office and complete lessons learned and add new elements, to mitigate risk, to enhance safety. It's kind of an ongoing evolution of the work method, to the point where, in the video, it was showing our 735 kV lift system, which is a massive lift system. We're lifting towers and wire systems in excess of 130,000 pounds, on that voltage level, right? So it's an evolution that happens, we build on our previous capacity. We're lifting line angles, dead ends, helicopter access, all of our equipment into entirely inaccessible structures. These are methods that have evolved and developed over time, and just building in experience, incorporating, when we do have to take an outage to be able to complete the work safely, we've incorporated very detailed, relatively complex tension mitigation strategies, right? That again, building on the experience that we have established previously.
Then I'll add to that too. Sorry, jumping in on you, Luke, there. But talking about like the evolution of the technology and what we can do, like Nathan mentioned, we've kind of even taken steps further now. We're raising guide structures, tubular steel structures. So, we're evolving into different type of tower types, not just lattice, as we move forward as well, because, as we're looking into the market and realizing, all right, there's, a lot of tubular steel that's been out there for 10, 20, 30 years now. They're having the same problems that the legacy lattice structures are having. And, we have to move in and evolve with the marketplace as well to meet the needs as those lines need more capacity in them. Guide structures, again, same thing. It's a little bit more of a synchronized lift because you got to, have everything moving at once. But the point of that is we're continuing to evolve with the market. And if clients are looking for opportunities to raise towers that we simply haven't done, or a work method that doesn't exist today, doesn't mean that we wouldn't develop it to be able to safely raise a tower for clients to meet the needs in their system, their network needs.
No, thanks both of you. I guess the only thing I would add, just for, I suppose, a more of interest sake, and then hopefully to ensure that our potential clients out here or who are listening understand as well, is so as Nathan said, we've evolved from lower voltages to higher voltages, and really that's only because with higher voltages comes larger loads because span lengths get longer and structures get taller and such. Ultimately, voltage level is, again, I don't want to downplay it, but it's sort of irrelevant in the sense, as long as you're maintaining all of your safe working distances. So, talking about that, whether it's 110 kV or a 735 kV, sometimes 735 kV structures are easier to raise than 110 kV just because there's more room on the tower to work with. The equipment's larger, the access is probably better, but comparatively to the 110, which is sometimes 100 years old, it's harder to get to. There's more congestion, there's more lines built around it. So some of those lower voltages actually come with more challenges than some of the higher voltages. So, it's not a straightforward answer, but why I wanted to bring it up is, again, we have clients who say, well, my line is 100 years old. I would never even consider upgrading it. All I want to do is tear it down and build new. We've raised dozens, if not hundreds, of towers that were 100+ years old. There is so much existing and potential life extension in our existing infrastructure that it is very economical and crucial to look at it. Trying to tear down an existing line and rebuild a new one comes with significant challenges. Being able to upgrade it, almost from a maintenance perspective, almost employing the whole idea of it's a maintenance project. It's capital, but it's almost like using a maintenance plan where you have access already to those structures. You're and upgrade them. You're allowed to maintain them. Is a big benefit to utilities. So really what I want to touch on is don't just think that it has to be a structure that's no more than 30 years old, or or it has to be in this location for us to consider it. We've raised and repaired and upgraded and synchronized with high temperature cable installations and foundation upgrades for new circuits and all kinds of things, phase separations. We've looked at many applications and they're always viable, right? So it really, I want to just nail that down, is don't think that because your line is older that it isn't worth having a look at.
That's really interesting. That just raised another question in my mind as you were responding to that, and I'm getting a couple questions coming in here, but I want to follow back up on that. So, again, I'm not an engineer. I don't know the answers to these, but if you're raising infrastructure that is up to, say, 100 years old, and you're winding up putting in presumably new steel as part of that, what are some of the engineering challenges associated with combining those old steel aspects with new steel, or am I just like totally off base on that?
Go ahead, Nathan.
Yeah, I mean, it's not that you're off base. It's that it's an engineered approach. It's the whole project the projects we get involved with start with a feasibility. All right, so we look at the existing structures. We look at what information does the utility have on those structures. Sometimes it's no information. Sometimes we've got the structure, we don't know what the details are, and we develop an audit plan and an inspection plan, and we'll generate a full as-built record for the utility of those structures, right? We'll daylight elements of the foundation to determine what is below ground, right? So it's not just vintage of steel that we're combining, but we're completing a full engineered upgrade to the structure, right? So that is part of the modeling and the analysis and the detailed design that makes up the ultimate delivery of the project.
Yeah, interesting. So one of the questions that came in here is it goes back to the question around voltage again, and they're asking, what's the maximum voltage rating and weight you can raise the tower?
So that's a beautiful thing about an engineered system, is that there is no maximum. It really comes down to the tower, the existing structure, and the economics and safety behind it. So voltage, we can always find it if we design it to operate at a certain voltage, there's always a safe working distance associated with it. So there's no maximum voltage. Sorry, what was the other part of that question? The voltage and
weight and
maximum
load.
voltage and maximum weight you can raise. Yeah.
Thank you. And then from the weight perspective, again, because it's an engineered hydraulic system, we can design to basically any weight we need to. The challenge becomes, is it affordable or economical for a single tower versus a project that may have dozens of those structures? if you came to us and said you had this monster of a tower that weighs this, and it was access was terrible, but you only had one of them, there might be some sticker shock associated to the designing, fabricating, and developing a system for that one structure. But sometimes that's the way it is, and that's what it costs. On the flip side, if you came to Ampjack and said, "Hey, I've got a 765 kV line that is got 5-bundle conductor and big wire, heavy, and I need a system that can help raise that, and my access is pretty good and all that, and I've got 20 of them to do," we can be very, very economical with that. So there's no real limit from a safety perspective. There's criteria, economics, and sort of the balance between all of that operations that come into play before actually having a max limit. Nathan, you want to expand on that at all?
Yeah, I mean, I think you covered off. It really comes down to that trade-off. We with an engineered approach, we can do a quick feasibility study for a client and pinpoint a lot of the variables that go into pulling together a very detailed pricing proposal, and we can do that quite efficiently. And so there are a lot of variables that go into the ultimate design and analysis that goes into before getting to construction. Again, I kind of feel like I'm just repeating really what you said, Luke. Yeah.
Let me give an example. Maybe this will help clarify. So when we started raising lower voltages, right, we had systems that we designed for those weights associated to those voltages. We technically often class our systems by voltage, but we really shouldn't. We should be classing them by capacity, but it's just a trap that we fell into ourselves. Regardless of that trap, ultimately, we developed systems for associated capacity or voltage at a time. As we increase our capacity with new, larger systems for larger or higher voltages and larger capacities, now we've got systems that have, again, larger capacity. We've gone back in time and we've actually been able to raise structures, let's say on a 115, 138, 230 kV line that 5 years ago we weren't ready to raise because the loading was such that we didn't have a system that could handle that capacity. Now we do, because we've got tower raising systems that'll lift a 735 kV structure that weighs over 130,000 pounds. Well, it can handle significant side tensions and imbalanced loads that we weren't ready to tackle 5 years ago. So there's an evolution, like Nathan says, and the max is not really a fair bar to set. It's really is what can we do economically and what can we do safely.
Great. Well, I want to get one more question in because we're getting close to the top of the hour, but it kind of goes back to, I thought that video was great because it teed up so many different questions just from watching what was going on there. And you touched a little bit on this, Luke, earlier, but I'm just curious, a number of those images from the video, the crews were out there working in the snow, raising these towers, and I can't help look out my window and see the snow today. And it just made me think, to what extent is the weather an impact on working on these systems or influence how you go about doing it or not? I mean, I'm assuming you don't do it in a hurricane or a blizzard, but otherwise it looks like it's pretty much any time.
So again, it all comes back to safety, right? So whether it's design safety or it's operational safety, let me put it this way simply. The Ampjack operating criteria, what we designed to, so it's a 4-to-1 safety factor at a 25 mile an hour or 40 kilometer an hour wind. We won't separate a tower if the wind's coming to that. Or we've got a temperature rating from something crazy like minus 25 degrees Celsius all the way to 110 degrees Fahrenheit. And, so there's a huge window of operating ability. It really is going to come down. It's not very often we get anywhere near that operating criteria before we stop our crews from working because it's just not a safe environment anymore, right? So the system has got this very, very large operating capacity that rarely gets challenged because we typically look at the safe working conditions for our crews and stop before that. Do we have special systems or have we looked at things for high wind areas? Yes, we've looked at, criteria for some of our clients who have, high winds, and we'll say, okay, well, we'll design a system that can handle over 40-kilometer or 25-mile-an-hour winds. But those are rare occasions because those are high winds. Ultimately, though, we don't want our personnel working in those conditions, unless there's a very big need for it.
Got it. Well, listen, Luke, Nathan, Mike, thank you very much for your time on this. Very interesting process, and it was great hearing, having the discussion to find out a little bit more about this. So appreciate your doing that. And we will put this, for people who are watching, we will put this on our website, so you can watch it afterwards as well. And I think we'll probably be able to put the video on the website for people to watch if they want to just get a smaller snapshot of what's going on with this. So thank you guys again for participating in this webinar series, and really appreciate it. For the people who are watching, I just want to mention ahead of time that our next one is going to be on February 14th, Valentine's Day at 10 a.m. And we're going to have Ampjack come in and talk about how they use sensors and data analytics for their grid monitoring processes. So looking forward to seeing that presentation as well. So we're going to wrap this one up for today, and thank you guys at Ampjack for your presentation. And we look forward to the next one of these in our series. So thank you.
Thank you for the opportunity.
Thanks, Larry.
All right, bye now.
Bye-bye.